I would like to invite Mr. S. Kumar, who is the Director of Cape Electric, having more than 27 years of experience in electrical safety, lighting protection, EMI and EMC of electrical installation. He has been conducting various seminars and webinars all across the country, and I know since last 1 week he's been traveling to district in Kerala, length and breadth, and addressing all the electrical engineers over there and talking about the importance of electrical safety. And he has conducted many studies on failure in electronic equipment. So today's subject is one among that. And he is the member of working group of IECA and IS Technical Committee. And as all of you know, that he is also the member of the National Building Code 2016, and he has contributed immensely on various electrical safety standards in the group. I give this platform to our speaker, Sri S. Kumar.
Thank you very much, Mr. Dominic. I hope my sound is clear.
Yes, sir.
I'm not switching on my camera because I'm in a place where the internet bandwidth is too low. So let me start the presentation. Okay. Now, my subject is protection of modern electronics, fundamental requirements in the electrical system, because the electrical system must be stronger to support the electronic installations in case of any kind of failure or any kind of a disaster. So I will just touch up some of the subjects which is very much mandatory. Just for the information of the participants, Cape Electric is a company involved in several business activities. We are into a lot of large-scale training of electrical engineers, but most of our trainings are not charged. These are free trainings. We are giving a lot of training classes. We are doing earthing and shielding and other things for on the electrical installation level. We have double insulated electrical enclosures. We are also having a company, we are also doing some kind of EMI, EMC and some small jobs, but with respect to the electrical system level. Our company is 25 years old. In fact, we are in February 2022, we will complete our 25 years of service. So now with respect to the subject, my subject, all of you know that EMI and EMC, it has got a source, a coupling path, and a victim. And also the intentional electromagnetic pulse, which is becoming an important subject in the future. That means even electromagnetic generators, those are mounted in vehicles, can come to smaller installations, and it can destroy electronics. These are going to be the threats of future. So what we should do is, protecting electronics is the important subject, but the electrical system in the sense, starting from the transformer, your electrical distribution boards, and all those parts shall offer certain or shall satisfy certain rules and regulations. Then only the EMP protection itself is possible. So the concept which is followed for electromagnetic or EMC protection is multi-barrier protection, in the sense, one moment, I just, okay. So multi-barrier, the protection concept is called as a multi-barrier protection. This is the one recommended in IEC. See, IEC 61000 series of standards talk about the EMI, EMC. So there it explains what you should do to an electronics to protect, and what you should do for an electrical system and for a building and so on. Basically, against conducted and radiated effects of various kind of EMIs, a multi-barrier protection method is recommended in the IEC standard. Now, once when we come to the electrical safety standard, such as our IS 732 or IEC 60364, the same concept which is followed for protecting electronics is also adopted in the electrical safety standard, and the same similar things are followed everywhere. Earthing, for example, earthing means equipotential bonding. If you make a very good equipotential bonding system, then your equipment will be very well protected. Now, with respect to the conducted and radiated surges, this is a symbolic representation. Each one is talking about, as Pandays are told, first barrier, second barrier, and the equipment. So there are barriers at various levels. Now, IEC is recommending a six concept protection plan for a facility. 6-point concept or 6-part conception, protection facility means the first one, the first shielding, for example, here, the first shielding or the barrier shall protect. This is actually your building. Your building must give certain amount of electromagnetic shielding against conducted and radiated surges, for example. Now, if we have a good quality electrical building, which is supporting to a modern electronic equipment, preferably the concept 3 or 4. This chart is actually from the IEC 61000. 2, 3, 4, and 5, they recommend this phenomena or this kind of a protection scenario for protection of buildings or electronic equipment in buildings, civilian facilities. So the protection concept 4 or 3 is actually possible if we design and install our electrical and electronic installation, or if we design our building in order with an aim to protect the electronics from such disasters of EMI. So with the concept 3, for example, the radiated disturbances inside the building, it still goes up to 5 kV, and these are the limits which is produced. Now, what I am trying to explain to you is, if you look at the any of the international, any of the standards with the EMI, EMC, the foreign standards like American standards or British standard or whatever, what they say is the basic electrical system shall satisfy the national wiring rule. That is regarding the safety. For example, if we look at the American standards, they always say electrical system must be as per NEC or NFPA 70. Both are the same. So over and above this, the other additional safety features are built in. When it comes to India, we have the IS 732, which is equal to the IEC, NFPA or NEC of America. This IS 732 is from IEC 60364, talking about the design, erection, and testing of the electrical installation. There are 4 major safety measures which we are supposed to include in the installation, out of which the 4th one, voltage disturbances such as fault in high voltage. The 4th one is the subject which is talking about EMI or protection of electronics. One of the first subject here we have to discuss is the system earthing. System earthing in the sense, how are we going to earth the electrical system? Electrical system earthing is classified into TNC, TNCS, TNS, TT, IT. There are several classifications, but preferably for a large scale area, a large scale installation where you have your own transformer, we are supposed to go for a TNS system for electrical installation and IT system for some of the critical items. But when it comes to India, the TNS is very clearly specified and written in the standard. But the question, are we following it really, is a question. Once when it comes to equipment earthing, electrical equipment earthing, the earthing, there are different purposes for earthing. For example, with a different application, I always try to explain this subject in detail, but today our subject is not about earthing, so I don't want to explain it much. So one should understand the purpose of earthing and do it, like safety earthing, what to do, protective earthing, what to do, functional earthing, what to do, equipotentiality, what to do. Here, the biggest threat in our country is the misinterpretation of the standards. What we generally do is transformer neutral, 2 plates connected to 2 plates, body connected to 2 pits, and each building having multiple earth electrodes. Last week I was there in a data center. So they have about 70 earth electrodes all around the building. Few weeks back, I was in another data center. They have about 145 earth electrodes all around the building. So such installations are in real danger. They cannot think of protecting from EMI, EMC, HEMP anyway, they cannot even think. But still, they cannot even think of basic electrical safety, because the basic electrical safety things are also violated. Lot of buildings nowadays have this kind of earthing: clean earth, power earth, lightning protection earth, separate. This is also a big mistake. I request, please don't do it. Lot of earth electrodes, then interconnecting everything under the soil is also a wrong method. This is not the standard, or this is not technically what is recommended in the books or what is recommended in the standards and practices. Every building, the first part, if you wanted to protect any electronics, you must have the protective equipotential bonding. Of course, it is implemented for mainly for shock, protecting people from shock hazard, but it has got a role in protecting electronics as well, because now the concept of functional earthing comes into the picture, and you have to integrate protective earthing and functional earthing in a building. So if you don't have a protective earthing system in your building, of course, not even, as I said, EMI, you forget about EMI, EMC. You cannot even have basic safety. Your building will catch fire. If you have so many earth bits all around your building will catch fire during a fault. When we select electrical appliances in your electricity distribution in your building, at the point of commencement of supply, all the electrical apparatuses must be of category 4. That means a 230 volt item must withstand a 6 kV voltage impulse. The connected equipment must be of category 2, 2500 volt. These are the minimum voltage potential differences or voltage impulses the equipment are supposed to have. That means in your wiring, the minimum voltage impulse or the minimum category of the equipment is category 3. Connected equipment is category 2. There are equipment called as category 1. That means highly sensitive electronics. These highly sensitive electronic devices, we are not supposed to connect directly into a public LV supply. From the transformer, we are not supposed to connect. But this is actually the fundamental of protecting electronics or protecting the electrical system. If we really look into it, the question, are we really doing this in our electrical system, is actually a big question. Then the second part, which is influencing the protection of electronics, is temporary over voltages, the equipment selection, the electromagnetic EMI current loops, and SPDs or filters. What is current loop or temporary over voltage? Temporary over voltage in the sense, in case I am just showing you a picture of a transformer, there is a fault, the indication of a fault. Here I am moving the cursor, a fault on the HT side of the transformer. Whenever there is a fault on the HT side of the transformer, there can be problems. TOV at the equipment means the equipment may burn. People may get a shock. Somebody touching an equipment may get shock. A good electrical installation must have protection against this problem number 1. That means whenever there is an electrical fault at the high voltage side of the installation, low voltage equipment must withstand it. And the permissible power frequency stress voltage is 1200 volt up to 5 seconds. That means every electrical equipment are supposed to withstand, or every electrical equipment connected to the electric mains supply from the transformer are supposed to withstand 1200 volt up to 5 seconds. But if we really look whether are we really doing it is a second question. Similarly, whenever we use a protective device or whenever an electrical installation is made, one of the important safety measures to be included is reducing the current loop. So current loop in the sense, and the best practice is you should route all your conductors at the same place, the same route. So as shown in this particular picture. So if you have a large loop, then the large loop as the first picture, it may create a lot of problems, additional problem. Basically, you lose the safety. Inductive coupling. For example, there is a electrical line. You have an SPD or a filter. The outgoing of the SPD, if the wire runs parallel to the incoming, then of course your equipment will fail. There is no safety which is ensured by the SPD. So segregation of the circuits, the input circuit and the output circuit, it has to be segregated properly so that unnecessary failures are limited. SPD or the surge protective device is an important product or an important component in our electrical system. What it does is it reduces the radiated electromagnetic effect or radiated electromagnetic pulse. What do? We have SPD and we take wires and connect the SPD. We should understand that the effective voltage which is going into our system is the addition of the voltage drop in the wires, the protection level of the SPD and so on. What is recommended in the standard is you have to have very, very short wire. If possible, the wire length has to be 0. But unfortunately, what happens, if we look at 100 electrical SPD installations in our country, almost 80 electrical or almost 80 SPDs are installed in this fashion. The wire length recommended is 250 millimeter, but more than 2 meters are used. As a result, most of the cases, SPDs are just like, namkewas. It won't work. For this particular purpose, you must use special SPDs like the bus bar mounted SPDs. The advantage of these bus bar mounted SPDs are you are directly mounting on the bus bar. As a result, the voltage drop, the line length has been nullified. There is no line length applicable. I'm just showing you a test result of an SPD. The first one, the blue line, is the voltage protection, the effective voltage protection level of a DIN rail mounted SPD, and on the other one, the black and the red color are the effective protection level of a bus bar mounted SPD. Here, let us say, for example, the surge of 40 kiloampere, which is a very high surge, 40 kiloampere surge comes, the actual protection level offered by your DIN rail SPD is approximately 16 kV. In comparison, the bus bar mounted SPD, the protection level is actually less than 2 kV or something about 1 kV. So the problem of DIN rail mounted SPDs are once when the rate of change of current is higher and higher, more voltage drops on the connecting wire. As a result, most probably these devices won't protect your electronics. So you need to have really good quality product or good system like the bus bar mounted SPDs. Similarly, we should also understand that, for example, lightning, which is also an EMP, is not a one-time phenomena. Lightning probably is coming, very frequently. Maybe one strike itself within 5 seconds or within 5 minutes itself, you will have multiple strikes. If we look at the conventional DIN rail mounted SPDs, these SPDs are tested for one pulse. Then the temperature, the SPD will heat up, the temperature is brought down to the room temperature, and then the next pulse is given. That means the testing in between the pulses, it has got a certain time, the cooling down time. This is allowed in the standard, but the lightning will not wait until your SPD cools down. It may come quite frequently. These bus bar mounted SPDs are tested for multiple strikes. Say, for example, 2000 numbers of 10 kiloampere strikes, 100 strikes of 65 kiloampere. So once for critical electrical installation, you need these kind of high quality SPDs. As the shielding, now I skip this part. When it comes to lightning protection, all of you knows most of our the critical electrical installations, such as the metro rail, SNT buildings, or the SCADA centers of the power transmission companies, or the data center. A lot of places still the lightning protection as per the French code NFC 17102 early streamer emission devices are used. But please understand that the early streamer emission standard, which is the NFC 17102, the picture which I am showing is how to install an early streamer emission device. Early streamer emission, it is not a magic device which attracts lightning from 100 meters and sending it directly to the earth through one down conductor. This one rod, one down conductor, one earth electrode is actually a foolish idea. The standard recommends a proper equipotential bonding system. The French code explains a proper equipotential bonding system. Whereas in a lot of places, what happens, the rod is there, one down conductor, one earthing. The serial number, item number, serial number 2 to 18 is missing. Only one rod, and most of the time with long wires. So you forget, it won't work. Now, the last part, whenever your electrical system is completed, we are supposed to verify the system, which includes the inspection and testing. Similarly, an electronic system, during commissioning or after commissioning, we are supposed to comply the compliance as per the IEC 61005 standard, electronic system and information technology equipment. After installation, we are supposed to do a testing, or I'm not talking about the testing of an electrical item or a device. I'm talking about the testing of the entire system, system in the sense starting from probably an UPS and all the items which is connected on the electrical network. So this testing is also compulsory, but most of you knows this IEC 60364, 10 tests are recommended in our IS 732, but mostly we don't do it. Similar is the situation for the EMI test. Mostly we are not following. So basically what I wanted to tell you is, in order to have a high reliable electronic system, high reliable in the sense, not even from the EMP point of view, but for having an electronic system which is protected from normal situation, like a fault from high voltage line should not affect the low voltage electronic equipment. So a lot of basic safety measures are necessary. But unfortunate to say that in our electrical system, are we following those things? Is if I ask the question, most of the time it is not. We are still following an earthing system which has been discarded since 1937 or 1940s. Still we go for this, 2 for neutral, 2 for body. This concept, this concept don't exist, but we still follow it, which is the first enemy of protecting these particular things. By this, I would like to stop my presentation.